types of assignment operator: copy assignment and move assignment. As I mentioned before, these operators are required to be part of your classes, and you have to implement the assignment operators if you have pointer data members, pointer data members. If you don't have pointer data members, the member copy assignment operator provided by the system by default is good enough. So today we will continue with some operators which relate to arithmetic: increment, decrement, and then comparison, equal, not equal, less, greater, and subscript. And I will go over this in a big, not big rush, but a kind of quick, so we can start talking about the last topic for overloading operators, which is overloading plus operator minus, and in particular output and input operators, because you have to use for your assignment implementing the output operator. So this is what we have covered, and you should be aware that of the difference between assignment operator and copy constructor and the notations. Know that the system provides many tasks for us relying on shallow copies when pointers are involved, and I mentioned what those tasks are. And with C++11, to speed up the running of the programs, move semantic was introduced. Move semantics. So this is a place where you should try to get information if you have problems with these issues. Today we talk about pre and post increment and decrement operators. Assuming that I is 5, this notation gives you post increment, this pre-increment, depending on the two plus are placed. Before pre, after post symbol, post decrement and prefix decrement. In principle, these are operators which are used in for loops. Remember, they are used with arithmetic, pointer arithmetic. When you move to the next location in a sequence of memory location defined with pointers, you use pointer plus plus, meaning go to the next element. So they are quite common. For us, it's important to know what are the differences and how you can implement them for your classes. Notice that both take one argument, we have seen I, and for prefix operator, what we do, we increment the value of our current object. This is how real complex numbers, we are talking about the complex means going to the next. You just increment the real part, if you have. This is a mathematical kind of understanding. If we have this complex number, 3 plus 2i, the next one would be 4 plus 2i. So only this is incremented. This is what the convention was used here. And to make our type efficient and consistent with how these operators are implemented for native types, int, Boolean, and other types, it has to return reference type. So be aware, this returns reference type, this doesn't return reference type, because post increment is not allowed to perform itself several times. Where the first notation you will see in the C++ reference, you are allowed to do this plus 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 I. It's not recommended, but you can. So if I is 5, you end up here with 6, and then you increment again, so at the end you get here 7. So you are allowed, but I plus 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 is not allowed by the system for native types, therefore you return it by value. Things like this, which are a little bit not intuitive, makes C++ a little bit difficult to cope with, and some people complain about that. But this is when you try to make too many people happy. You end up with a lot of quirky rules. So if you return this by value and you return this by value, it's not a big mistake in our environment. But be aware, this is a way the language is, the language standard recommends the prefix and postfix to be implemented. So we have talked about return value, okay? Now, about parameters. You know that this, when you invoke plus plus I or I plus plus, you don't take any arguments. How the compiler can distinguish between them? The standard committee has decided that for postfix we take a dummy int parameter. So now, if we want to provide postfix operator for our types, we have to put this parameter, which is not used anywhere, as you can see, but it makes the compiler able to distinguish between prefix and postfix. Okay, this is the rule there. And now for implementation, as you can see, for prefix, simple, the current value is adjusted and returned. Okay, by reference, so it can be changed again. For postfix, there is a different approach. Notice that we have here a local variable constructed from the current value. So this is step 1. The current value is implemented and returned. Because of these 2 steps, you have situations like this. Let me see. Okay. You can perform things like that. I is declared to be 9. And then we declare an integer j to be I plus plus. At the end of this statement, j gets the value 9, I gets the value 10. So be aware, j gets the value I, which is somehow the value which was stored there, and then I is increased and we get that value return, right? Which doesn't happen if we have the same variable I and we declare a variable int k and we say k equals plus plus I. With this, the value is straight incremented and returned. So with this k and I ends up with both the value 10. So both of them, k is 10 and after this I is 10. This is one issue you have to be aware. Now, if you put in for loop where you practically don't really use the value of I plus plus, if you have a for loop where I is 0, I less than some n number, and then you have plus plus I, or I plus plus. For this case, what we want is to increment I, and I is incremented every time you go through the for loop. But practically you don't assign this value here at this moment. It doesn't matter which type you use, which syntax, plus plus I or I plus plus. But as you can see here, when you use postfix, you have a memory allocated, which takes a little bit of time. And if you do this 1 million times, the for loop, million time of split of nanosecond adds up, and it's recommended. It doesn't make much sense for integers, but sometimes the these operators work with a pointer, iterator, and they move, and they might take more than that time. If we have an iterator, it's a class which might come with some other data values. So when you construct a local variable, that local variable to be constructed takes time. That's why you will see in some document, whenever you use incrementing, and in cases like this, it's better to use plus plus I. It's not the end of the world if you use I plus plus. Why people use I plus plus? Some people argue that it's used because we have C plus plus, and then people say I plus plus. And as this notation, plus plus I, it's not so widely spread. Anyway, conclusion, you should know the difference of the heading of your operators, the dummy parameter used, and the fact that in the postfix you have some extra steps performed. Okay? Now, the last thing I mentioned, they argue that it's good to follow reference constant and by value as is there, because some standard template library tools rely on this type of return value. That's why sometimes we have to read very careful the documentation, and in particular we will see later for sorting and searching, sometimes you need to follow example. Now, notice that this operator is a member of a class in general. In general, it can be a global function. It can. The language does not forbid this, but in general, it's a member of a class, like the assignment operator. Comparison. To compare two complex numbers, we can have it like a member of a class. Again, it can be not necessarily a member of a class. When you compare the current complex value with this complex value, neither change. You return true or false, whether they are identical or not. Therefore, as a member function, it has to be constant. And this tells the compiler, I am not changing this value. I am not allowed to change this value. Okay? It takes a reference constant, again, efficiency, avoid copying sometimes very large structures or classes, and it's no semantic to change, as I said, any of the values you compare. So as you can see, this is not verbose. Some people say, if this equals this and this equals this, return true, else return false. You can write code like that, but it's much simpler. If they are identical, that's it. It returns true. If not, it returns false. So why use if then if it's possible like that? Okay, any questions? So the Boolean is a return value, right? If they are all equal, true and true, returns true. If at least one is not identical to the other, returns false. Now, if we have two complex values, we can do very simple testing like that. We don't have to go and look at the individual members. We are not allowed for complex class. But as you can see, we compare our complex values like we compare integers or Boolean values or float values. Very simple with the comparison operator. And we do whatever task we want here with that. So, C++, remember, you can compare string variables. You have string hello and string there. And you can check for equality with things like this, because the equality operator is implemented. And you don't need the C-type function string compare. We have seen the strings have not only this operator overloading, but provide functions to perform more fine evaluation. Right, now, it's not a strict rule like for classes with pointers, but if you implement equal testing, it's normal to maybe implement not equal. And normally, what you do here, you just call inside the function the equal operator you have defined. Return not others equal this. This is how you do very simple and consistent coding if you want to implement these two. So they come in pair, and in many cases you implement one based on the other. So greater and less, greater or equal, less or equal. And for all of them, as you can see, they are not allowed to change data members on the objects they work, and they are not allowed to change the argument. This is a way to work with them, and all return full. Now, if you design a type for which sorting is required, as it will be in some of your future assignments, sorting, you have to be able to compare one element with another. So, if you want to compare two students, you design, you have to provide something like this. When a student is considered less than the other, maybe its ID comes before the other ID or something. So, the sort algorithm, which is provided by the library, a standard template library we'll talk later, relies on having this less operator defined. So this is mostly the case for things which you have to do arithmetic or comparison. You have to think about what has to be implemented. Subscript operator for types which somehow are modeled based on the C array, try to make the C array types safer. They normally work with index operator. Vector has index operator. You will see your C array has vector operator, double-ended queues, and some other. You might want to design an array, sorted array yourself, type. The array class provided by the C11 has an index operator. Right. This operator is used with containers, collection of objects of the same type in particular. And if we go and look at our array class where we have just two data members, keeping track of how many elements were stored in the array, and m values, which m values is a pointer to the array elements. So we consider an array with these two data members, with constructor, destructors, all the 7 methods. We want to allow for performing index operator. Notice that you take the location of the element you want to work with. So this parameter is the location where the element is sitting and return a reference type. We are talking about a pointer to array here. So if we are working with a valid location, remember, location starts with 0, ends at m size -1, then we access the z element. So m values is something like points to a sequence of elements. This is location 0, and this is m size -1. We have m size elements here. And when we have a value between this, for example I, and assume that our array stores their integers, 9, 3, 1, -7. With that operator, we return that location 9. Why we return a reference? And maybe this will help you to understand better what does it mean to return by reference. We return an integer, right? 9, but why by reference? It's a primitive type. We don't gain any efficiency returning by reference, but we gain a different thing. Remember that the index operator can be used in both places, on the right and on the left side of your assignment operator. Remember that we have, if we have an array of elements, an array like in C, okay, with some elements, let's see, here, 0, 1, 2, 3. We can say A1 gets the value 8, or we can say another integer I gets the value A2. Notice, it can be left value, but it can be a right value as well. What does it mean? Okay, this is easy. When you just look at what is the element here and copy it in I, returning that m values, it's clear. You copy that value and store it in I. What happens here? For this one, you should be able to be allowed to store the value. So in A1, we store the value 8. But this is a function. So you have to be able to change the value of the return value from the function. And this is what reference return is. Somehow similar, but a safer way, function returning pointers. Right, so return by reference, like here, and for any other types, complex, whatever you want, means that you are allowed to change the value you return from your function if necessary. You are allowed, like here, okay? Right, so in particular, you have to remember that index operator can be on the left and on the right side of the assignment operator. So you should be able to store data with this. Now, if you have a constant array, it's a different story. With a constant array, be aware that this operator doesn't work, because with this, you change the value of the element, which is not allowed when you have a constant array. Therefore, just in that case, for constant correctness, you have to make your operator constant. Be aware, this operator is always a method of the class. Has to promise that it won't change the value, right? It doesn't change m values I. And the return value is now constant reference, because constant arrays can't be changed. With this, why would you need something like this? If you have a constant array, what is the use? You might want to print data in the constant array. And then you have to have access to index operator to print individual elements, which normally doesn't change the value of elements. So be aware, in general, the index operator, if you read the references, is provided in both forms. This constant, like here, or this form. Both are provided. They are, the index operator is overloaded. So constant overloads functions, be aware. And you have a string type example in your stream, and you will see that you have both non-constant index operator and constant index operator. This is how things can work. As you can see, if the value is not, I is not in the proper range, what should we do? Normally, we have exceptions trigger here. Otherwise, you just ignore this or assert. We will talk about assert a little bit. So as you can see from CPP reference, user-defined classes that provide index operators should have constant index operator and non-constant index operator. Notice that here we have struct. In C++, struct and classes come with the same features. The only difference is, in a struct, everything is public by default. In a class, everything which is by default, it has no visibility specifier, is private. Here we have no visibility specifier, everything is public. You can put public and private in a structure. You can have methods, you can have index operator, as you can see. Remember size t? I mentioned it before. Size t means unsigned int. And it's there so you don't have to check for positive values. And you have to use it for your assignment 1 part 2. This is the only thing. It's another name for unsigned int. And as soon as you put your index or values to be size underscore t, they are checked to be positive, otherwise things will be not okay. So here this is returning whatever was the type for elements in this construction, m vector. So value underscore t is a type of elements here. We don't know, it's not a predefined type in the standard library. So the value type is known to a built-in type. If we are working with built-in type, this has to be returned by value, because we don't gain any efficiency. So be aware, if this is int, it can return by value, right? Instead of this, we just say return int. But I put it there to make sure that you understand the difference between int reference and constant int reference. Right. Operators are the one we have talked about. Some of them are members of the class. But sometimes we would like a little bit different approach, because it doesn't make sense and in particular at the end. Now, we are talking about the complex type where we want to add float values to constant. This is a constant, and I should be able to add 3.2. In other words, to add these together and get the new value. One option would be increment the real part with this value and return result. That is the one we have constructed here. As you can see, should be constant again and return by value. Now we have a number and we try to add this number with 5. Works because A is the current value. It's like invoking our operator like that. A operator plus with argument 5. And it's fine. But the next statement is an error, which shouldn't happen because addition is commutative. If you are allowed to do A plus 5, you should be allowed to do 5 plus A. Therefore, the next one, which will say float value 5.0 dot operator plus on A, doesn't work. The float value doesn't know how to add with a complex. So that's last case. Is not allowed. It's recommended for arithmetic operators and even for relation operators to make them not member of the class. You never know what might happen. Therefore, we want them global functions. Global functions, we know how to write them. This is the first element. This is the second element. We want to add them. They are constant, reference constants, no change to them, reference efficient. And what we do, we create a local variable in which we store those values, right? Result m value 0. So this is a new value, perfect, and we return it. Easy peasy. What's wrong here? This is a global function. It does not have access to private data members. These are private data members, m values 0, m values 1, they are private for the class. Global functions don't have access, except if we give them access. So be aware, private data members are not available to outside world, in other words, to this global. You can see that it's global. No operator here, scope resolution. So you can tell, this is a global function. Right, what can we do? We have to have accessors and mutators in our complex class. Get the real part, get this, right? This will give me access to this first operand real part, and then this gets access to the real part of the second number, complex number, right? So this is get real of LHS for get real of RHS. We add them, and for result we get set real. So another, this is a mutator. The class complex has to provide this method, set real, get real, and stuff like that. Like you will have for your student, get name, get ID. These are accessor. And then the same for imaginary. And after that, these are public functions in the complex class. Everyone, which includes the file where complex is defined, will have access to them. Therefore, everything works fine, and the result is returned, and we have got what we wanted. Right, so we have this plus operator to work with two complex. Now we can overload it to work with complex and float. Because we wanted to make sure that it's commutative, we have to provide float to complex. And it's a little bit verbose with this. It requires a little bit more writing from our part, but it's safe, it works. We have to write it like this and think, okay, what happens if I have an int here instead of float? What happens if I have a double? You remember there are some implicit conversions, so some of those will work. We don't have to implement for double, for int. We can if we want, if it's very important, but because of the conversion, this will work fine. Now, we have seen that some operators must be implemented as member functions, others as global function. They can be implemented as member function. Even for this one, you might have an operator plus a sign for complex and then have a global function invoking that plus a sign to do implementation for this case, a global function. Notice using some method, public method of the class. But we will see this approach because it invokes a lot of functions. Get image, imaginary, get real, set imaginary, set real, a lot of functions I invoke is considered slow. And therefore, it was a mechanism introduced to speed up, again, to make the language a little bit more efficient. And this is friendship relation. We have talked about composition relation, when a class can be used as a member data for another class. You construct a class from another class. We will see inheritance is another relationship, and here is another relationship, friendship. And this is, in particular, used for overloading input-output operators. This is a must, and we will see why. But be aware, we can have friend classes, not only friend functions. I would recommend you to read this part, but only the first part, before inheritance, not what follows. And here you have some dedicated pages about friendship, because everything comes with prices. Overloading operator can be done member functions, global functions. But for global functions, we need accessors and mutators. In order to avoid them, we can make the class give permission, the class give permission, not the function gets permission for itself. Be aware, the class gives the friendship privilege to some operators it considers important because they are used very often. Displaying something on a screen is a very common operator. Therefore, we want it to be as efficient as possible. And Straustrup was asked, oh, but if I make my class friend, if I make Z function a friend of my class, you will see, as soon as you make it a friend, Z function has the same privileges as the members of the class. It can access anything in the class for which is friend. And someone complained, is this not avoiding encapsulation principle? You make private data members available outside the class? And his answer was no, because the friendship privilege is given by the class itself. I know that I need to have this operator used several times. What I do, I declare it. It's a global operator, notice. As soon as you put friend in front of it, be aware, it's a member function can't be friend. It's already having all the privileges. But if you see friend in front, it means that it's a global function. It a global function which takes two arguments and return an argument. So if we talk about Z complex, this allows the operator plus to access everything in the complex class, including private data. Therefore, now this code is valid. I access private data member and private data member because I am a friend. How you write it? You write the function prototype inside the class. Outside the class, you don't put friend. You just implement it. This is a global function. And now this is very simple. So, it's not good to have every possible function a friend of the class because it defies the purpose of encapsulation. But the functions which really need the friendship privilege is the one which are most used, and they are in principle input and output operator, and they are something you have to deal with for your assignment. If we are talking about our complex type, remember, we want to perform output. We want to do something like this. Our type should behave like int type, like float, which is not an easy task to do in C. It's very difficult to do this, but with C++, you can do it very simple, because we can overload the output operator, like we overload other operators, right? So if I have our C class, all I have to do is implement operator output. It's never, input and output operators are never members of a class. Input and output operator are never member of a class. Why? Because they are public member function of OStream type. As soon as they are OStream type, they have to work with cout and file whatever. So be aware, operator output is a member of this class. And it comes overloaded, as you can see, in zillions of forms. Boolean value, short, unsigned, for all native types is part of the system. These are a lot of functions, as you can see. It's also called inserted operator. So be aware, they are not members of a class. Very easy to implement. It's a friend. If it's a friend, it has to have this heading provided in the complex class friend operator output. Now, it takes always two arguments. The output stream, I call it OUT, you can call it whatever you want. This is always of type reference OStream, and it's always a last statement in the function. So be aware, you have to return it. Again, because we want to perform multiple output. Anyway, so this is the first argument. The second has to be an object of the type itself. We are implementing this operator overloading for complex type. Normally, we need to have a handle to what to display. So be aware, this has always to be a method of parameter of the output operator, and always constant reference, because when you display something, you are not meant to change anything. Right? Return. This is what is returned. Therefore, this is the type of the return function. You will see. This is return. Therefore, this is the type. It has the advantage that you are allowed to change the output stream, performing change output. So if you have more complex types, we can do something like this. Display C1 first, display C2, display strings, end line. So after we invoke the operator and send C1 to the output, this output can be changed by performing more display. Multiple operators, cascading or chaining is the same thing. And these are things which will be repeated for your assignment. You have to pass this first argument to output operator you design for student class, for class, for a course class, because you have to provide one for each type. And then for the student class, you will have a constant complex student and return this stream output. And what you do, you send to the out of parameter whatever you want from your data members. Here we send bracket because we want to display our numbers like 3, 2 for this one. So this is displayed, the first real value, m value 0, is displayed comma, and then the second, which is m values 1, and close the bracket. This is it. For your student, first name, last name, whatever you want. With this, you can call it the output operator with cout, you can call it with files. It works perfectly, same way. The things to remember, you always have to have a second argument which has to appear here somehow, and you always have to return out. I have seen people forgetting about this, and this is a very interesting topic, and you will have it in your assignment 1, part 2, you will have it in test, you will have it in the final exam. So make sure that you understand the examples there. Why does return a reference to our stream? I already answered. To allow for multiple output. Okay. When we have it as a friend, we have to put it like this. Inside the class, we give privileges. And with this declaration, we can implement it as we have seen before, because it has access to everything. If you are to be very safe and not allow friends to your class, that's allowed. The method is define a print method, and then invoke in your complex class, this shouldn't be here, should be outside. Oh, sorry, no. When we call it, it's a different story. So we have a print method in the complex class which somehow parallels the output operator. As you can see, it takes a reference to a stream and returns a reference to a stream. A print method. Now it's a class method. It has access to everything, no problem. We have just to invoke when we want to implement our output operator. All we have to do is provide the same heading like before, but it's a global function non-friend. Assume that we have this. As you can see, complex doesn't give a friendship to output operator. So I want to define the output operator. Stream reference is return, and then we have operator, right? It takes 2 arguments like before. Stream reference, I will choose a very stupid name, X. Don't ever do this, but let's speed up a little bit. And then I want a complex, constant, complex reference A. And what I do here, inside this function, I invoke a print on X, return X, and I am done. So to overload, and after that I can use cout, first C1 object, second C2 object, whatever I want. As you can see, all is like before, the heading, it's not a friend, it just invokes this A object, which is second argument, with X, because we have there the output, the whatever output string we have used, and always remember to return this. So, friend or non-friend, it's same. See, the only thing is we have a function invocation here. Non-friend, it's safer. Right, input operator, we stop here and finish it. We have 6 slides. You will see the similarity between them, but we will try to do this tomorrow when we go over the review, test preview, and assignment preview. Right, thank you very much. See you tomorrow. Then if you have, we stop here at slide 12. Be aware I put on your stream 2 examples, clock class with a lot of operators, arithmetic operators implemented, and string DT class, where you work with pointers, constructor, destructor, index operator. Have a look at those examples. Probably I don't have time to go over them, but if you have questions about those examples, send an email, come to talk about them. Thank you very much. Sign out. Remember, assignment is due Sunday. Now you know how to overload output operator. It's the only thing you haven't seen, haven't been aware before. Term test Monday, final exam November 6th. Thank you very much. See you tomorrow.